This segment is going to be on truth tables. We're going to use truth tables to determine if a statement is true or false, given that we know whether or not pieces of the statement are true or false. We may not know yet, so we're going to look at all the possibilities. If we look at a particular simple statement, P, it's either true or false. We may not know which it is, but it's either true or it's false. Its opposite, or the negation of it, would be the opposite. So this is the truth table for negation. Just changes the truth or falseness to the opposite one. Let's suppose we have two statements, P and Q. It's possible they're both true, or that P is true and Q is false, or P is false and Q is true, or they're both false. Again, we may not know. For example, if I say, Catherine Swaglow has a pet cat, Catherine Swaglow has a pet dog. You may not know this, but either both statements are true, or perhaps I have a cat and not a dog, or perhaps the other way around, or perhaps I have neither. You don't know. But the statement "and" is true only if both pieces are true. Earlier we had the example, first president was Washington, the second president was Lincoln. That's false. So, because it was "and," it was false. In order for an "and" statement to be true, both parts of it have to be true. Otherwise, it's false. With "or," only one part has to be true. Washington was our first president, Lincoln was our second president. Or, it would be true. Washington was our first president, or Lincoln was our second, that would also be true. As long as one of the statements is true, or possibly both, the statement is true. These three are straightforward and probably make sense to you. This fourth one, however, is going to be a little more hard to swallow at first. These two also, by the way, are commutative. Remember the idea of commutativity with addition and multiplication, where you could go in both directions? P and Q is the same as Q and P. P or Q is the same as Q or P. Here we're going to look at the implication, or the conditional. True. If something's true, then something true. The whole statement is true. True implies true is true. True implies false is false. I think those two are straightforward. It's these two that start out with the false that are the difficult ones to grasp. If it's raining cats and dogs, then Washington was our first president. If it's raining cats and dogs, then Lincoln was our second president. Both these statements are true because it's never raining cats and dogs, so that part is always false. So the implication itself is true. The opposite of it is going to be false. It's raining cats and dogs, but Washington's not our first president. Is ultimately why it works. I know that's kind of confusing. At this point, you may just need to write this down or put this in your memory. The implication, the only way the implication is false is true implies false. It's the only false one. And notice it's not commutative. P has to be first. If P then Q, true then false. The other way would not work. Okay. We want to figure out how to get these rows in here, and in general, the number of rows equals 2 to the number of simple statements. The simple statements, remember, are signified by the letters. So in this first example, it's not really an example, it's a table that we're using. There's one letter, P, so 2 to the 1 is 2, and sure enough there are 2 rows. In these three, there are how many letters? 2, 2, P and Q, 2 to the 2 is 4, and sure enough, there are 4 rows. What if we had 3 simple statements? P, Q, and R, for example, P, Q, and R. Then we would have 2 to the 3, which would be 8. So there would be 8 rows. And we would start out by making half of those rows, if we have P, Q, and R, half of the rows would start out with true. So we'd make 4 of them true and 4 of them false. Half of these true ones would have their Q's true and half of their Q's false. Half of these false P's would have their Q's true and the other half would have their Q's false. Then half of these two that have both of them true would have their R true and half would have their R false. So you can take the number of rows you're going to have and cut it in half. Half of them are true and half false for the first one. Then take the number of trues and cut that in half. And then alternate 2, 2, 2, 2, and then cut those in half. And that would work with 4 as well. If we had 4 letters, there would be 2 to the 4th, or 16 rows. We're not really going to look at those, but that's how that would work. Okay, let's create our own truth tables using those 4 tables. Let's start with one that's P and not Q. The not Q, remember, has order of precedence. We have 2 letters, P and Q. So 2 trues, 2 falses, 1 true, 1 false, 1 true, 1 false. Now we're going to go across and make a longer table. Our work is going to be here in the middle, and then our table is actually going to be this part along with whatever our last answer is. So P and not Q, I need to first figure out what not Q is. Remember, not Q would be the opposite of these Q values. So true would be false, false would be true, true would be false, and false would be true. Now I'm going to put these together, P and not Q. This is my not Q column, and this is my P column. So I'm going to put these together with and. True, true and false, true and true, false and false, false and true. And you wouldn't necessarily write those, I'm just writing it to see so that you can see where they're coming from. True and false is false. True and true is true, false and false is false, false and true is false. Remember, the only true one is where both of them are true. So my table literally is, or my answer, as my truth table, is really these 2 columns along with this column. The rest of this is work, shall we say, in figuring it out. Okay, let's look at another example. Let's try P implies Q and Q implies P. This is the same thing as P if and only if Q. We don't use an equal sign because these are not quantities. We use a congruent sign, meaning that these 2 are the same. We only have 2 letters, P and Q, so those are going to be our 2 values. 2 trues, 2 falses, 1 true, 1 false. Many of the My Math Lab problems have these already set up for you. That way there's no checking of the columns. The rows can be in any order, but doing them all in the same order makes them easier for us to check. Okay, what do we need to figure out? We need to figure out what's in this parentheses, then what's in this parentheses, and then we can do the answer. So we've got to figure out what P implies Q is. True implies true. It's true. True implies false. Remember, that was the only one that was false. False implies anything is automatically true. Now we got to do Q implies P. So we have to do it in the correct order. Q is first. So we have to look at this one first. Q implies P. True implies true. It's true. False implies true. Remember, false implies anything. It's true. True implies false. It's false. And finally, false implies false. False implies anything. It's true. Now we can put these together. P implies Q and Q implies P. So that means I'm going to take these two columns, put those together. So true and true is true. False and true is false. True and false is false. True and true is true. So this one that's the same as the if and only if only works when those values are the same. Either P and Q are both true or P and Q are both false. Okay. Let's try another example. How about not P implies not Q. Again, I only have two letters, P and Q. So true, true, false, false, and then true, false, true, false. What's the order we're going to work this out? We've got to start inside the parentheses, give out the precedence in the order of operations. Which one's first? The not Q is first. After the not Q, I go up to the next parenthesis. P implies not Q. And then finally, not P implies not Q. Okay, so first of all, I've got to look at the Q column. So here, I'm looking at the Q column, and I'm doing the opposite of the Q column. False, true, false, true, because those are the opposites of the Q column. Okay, now for the next one, P implies not Q, I have to use P implies not Q, so I have to use P implies not Q. True implies false is false. True implies true is true. False implies false. Remember, false implies anything is true. False implies true is true. And then the last statement is to do the opposite of these. So the opposite of false is true, and the opposite of these is false. Okay, let's try one that has three letters. Let's try not P or Q implies R. And I've already made a grid here for us. So what's the first thing we've got to do? Let's think about the order of precedence. The order of precedence indicates that I would use the implication of the conditional. And so I'd have to do what's in these parentheses first, and inside of there is the not P. So I've got to do the not P first. Then next, I move out to the next level, not P or Q. So this is an or a disjunction. And then the final one, the not P or Q, implies or. So that's a conditional or implication. So first of all, I've got to do the opposite of the P's. So the opposite of all these trues is false. And the opposite of all these falses is true. And now I need to do not P or Q. So I'm going to use the not P or Q. So false or true. But only one of them has to be true. False or true. True. False or false. False. False or false. False. Down here, true. Look at all these are true. True or anything is going to be true. Right? True or true is true. True or true is true. True or false is true. True or false is true. And then finally, I have my implication line. So this whole thing is this column, or is this column. So true implies true. It's true. True implies false. It's false. False implies anything, including true. It's true. False implies false. It's true. True implies true. It's true. True implies false. It's false. True implies true. It's true. And true implies false. It's false. Again, really the answer, or the table, is really just these first three columns and this last column. This other part was the work that I did in coming up with my answer. Hopefully that helps you a little bit to work on the truth tables. Then you want to learn those first four. The ones, the not, the and, and the or, probably very simple for you to learn. Just remember with the implication of the conditional one, that true implies false is the only false one.